Andrej Karpathy, one of the most respected minds in AI, used a very deliberate word recently. Phase shift. Not evolution, not iteration. Phase shift. And that choice of language tells you everything. Phase shifts in physics are irreversible by nature. Ice melts into water and the system doesn't simply revert when conditions cool slightly. The same principle applies to software engineering right now. Once engineers experience AI coding agents absorbing the tedious, repetitive boilerplate work, there is no psychological or professional path back to doing it manually. Most headlines and LinkedIn posts are fixated on the surface-level observation. AI writes code faster. And yes, that's true. Coding agents can generate functional implementations in seconds that would take a developer hours. But treating speed as the headline is like marveling that the printing press made writing faster while missing the fact that it democratized literacy and toppled information gatekeepers. The speed improvement is the entry point, not the destination. The genuinely transformative story lives one layer deeper in the second-order consequences that most people haven't begun to think through. When the cost of producing working code approaches zero, classic economic theory tells us the bottleneck shifts upstream. And that's exactly what's happening. The constraint is no longer whether you can write the function, it's whether you know what function should exist in the first place. This repositions an entire category of skills to the top of the value stack. Systems architecture, domain expertise, product intuition, and the critical judgment to distinguish problems worth solving from problems that sound important but aren't. These capabilities cannot be easily automated because they require context, experience, and a deep understanding of human needs that models don't inherently possess. Karpathy introduced the concept of model speciation, and it's a framework that deserves serious adoption. The current AI landscape is dominated by a benchmark arms race. Who scores highest on reasoning tests, coding challenges, and multimodal tasks. But that monoculture thinking is already beginning to fracture. What we're moving toward is an ecosystem of highly specialized models, each optimized for a specific cost profile, latency requirement, domain, or deployment context. Think of it like biological evolution. Generalist organisms survive environmental chaos, but specialists dominate stable niches. A tiny, fast, cheap model perfect for autocomplete beats a massive frontier model at that specific job every time. One of the most underappreciated ideas Karpathy raised is the parallel between AI compute needs and the old SETI at Home project, where millions of volunteers contributed idle processing power from personal computers to scan radio telescope data for signs of extraterrestrial intelligence. That model proved something important. Distributed, volunteer-contributed compute can aggregate into something genuinely significant at scale. Applied to AI training and inference, this opens a democratizing possibility. Individuals and small organizations contributing spare GPU cycles toward collective AI infrastructure, rather than ceding all compute power to a handful of hyperscale cloud providers. The idea deserves serious institutional attention and engineering investment. Here's the transition that actually matters, and the one that will prove hardest for many experienced engineers. Moving your professional identity away from being someone who writes code and toward being someone who determines what code should exist. These sound similar, but they require fundamentally different mental models, different daily habits, and different measures of self-worth. An engineer who defines excellence as elegant implementation will struggle in a world where implementation is cheap. An engineer who defines excellence as correctly identifying which problems deserve to be solved will become exponentially more valuable. That psychological shift, letting go of craft as identity, is genuinely difficult, but it is the real work of this moment. History is consistent on this point. The professionals who thrive through technological phase shifts are never the ones who waited for the dust to settle. They are the ones who ran experiments while others debated, who updated their mental models before external pressure forced them to, and who repositioned their skills toward what the new paradigm rewards. The engineers who will define the next decade aren't necessarily the ones who were most talented in the previous paradigm. They're the ones willing to treat their current expertise as a foundation to build from, rather than an identity to protect. That orientation toward continuous repositioning is itself the most durable competitive advantage available right now. Karpathy's framing gives us a useful diagnostic question to sit with. Are you still defining your professional value by what you can produce, or are you shifting that definition toward what you can discern? The tools, the models, the infrastructure, all of it will keep changing rapidly and unpredictably. But the underlying principle Karpathy is pointing at is stable. In a world of abundant code generation, the scarcest and most valuable resource is clear thinking about what's worth building. That's not a technical skill, it's a judgment skill. And judgment, unlike syntax, cannot be deprecated.